Good afternoon, everybody. So my name is Nicolas Breyton. I'm the CEO and founder of Stellaria. And today we're going to talk about the innovation on the next generation of Generation 4 on molten salt reactors. So all you want to know about molten salt reactor, we'll have a Q&A right after. So I'm very glad to share this roundtable with Laure and with Isabelle, who will present themselves right after. So first I will start with Stellaria. So Stellaria has been created back in 23. We are providing the next generation of molten salt reactors with, so what are molten salt reactors? We will detail right after what we do. Molten salt reactors are of two kinds. It's actually a family where the fuel is liquid, right? So they are of two kinds, either thermic or thermal reactors or fast reactors. So today we're going to talk about fast reactors, and we will talk about chloride fuels. You have also another kinds of molten salt reactor with thorium and with fluoride fuels. We will not talk about that. So molten salt reactors enables the next generation of values for customers with more sustainability. And we're going to talk about sustainability today. Okay, so on my side for Stellaria, Stellaria is a molten salt reactor that is around 250 megawatt electric, and that provides the first breed and burn reactor in the world. So we fully regenerate our fuel inside the reactor, and we provide the next level of safety as well with 4 barriers, an underground reactor. And we think it will be able to provide more values for data centers and for customers. We'll come back about that in the next step. So I will introduce Laure. Laure, can you present yourself and your company?
Yeah, thank you so much. We have our picture now because it was like all Nicolas. Now it's, you can see that we are here. So I'm Laure Claquin. I'm the COO of Thorizon, you can say it both ways. So we are also a molten salt SMR developer. We have the particularity to be both in France and in the Netherlands. It started as a Dutch concept, and now we are around 50 people across the 2 countries. As Nicolas explained, and will continue afterwards, is to explain how molten salt is great. Molten salt has always been seen a bit as the Graal in terms of fission. And indeed, molten salt reactor, they have various, I would say, advantages, but they need also a lot of challenges to be tackled. And within Thorizon, we have the conviction that from an industrial perspective, we can tackle those aspects to enable to make, I would say, the fastest on time this reactor and this type of reactor that can unlock a lot of advantages. So we have a unique design concept, which is called cartridges, which is a patented design that enable a lot of practicality and modularity around the structure of the reactor. And the target is really to be able to increase the feasibility and also the modularity to then be able to convince end users and to unlock competitiveness in terms of electricity or heat generation. But we always talk about reactor design, but you don't have a reactor working without any fuel. And molten salt, as Nicolas explained, it's a liquid fuel that needs to be synthesized, that needs to be manufactured. And so we both rely on the, I would say, the competencies of Orano. And Isabelle will explain what Orano is doing in the frame of molten salt.
So thank you, Laure. Good afternoon. I'm Isabelle Morlaes. I'm working in the innovation department of Orano because we are talking about innovation today. And unlike my partners, Stellaria and Thorizon, Orano, the core business of Orano is the fuel cycle. So our aim is to support the development of innovative reactor by the development of innovative fuel. We support all kinds of innovative reactors, by the way. We have all the skills and competencies to develop the fuel for them. But more specifically, as a player of the closed fuel cycle, We support particularly fast reactor, the one who can are compatible with the recycling strategy. And in particular, molten salt reactor. This is a technology on which Orano has been doing R&D since 2019. We were very interested in this technology because of its ability to convert and to use minor actinides as fuel. We will come back after on this topic. Just to let you know, the fuel is liquid. It's like the molten salt reactor itself, it's very versatile. You can have a lot of variety of fuel. You can use a lot of fissile materials, uranium, plutonium, minor actinides, or fertile like thorium. We are convinced of the potential of molten salt reactor in the long term to convert the minor actinide. This is why we were interested in this technology.
Thank you, Isabelle. So we will talk a bit about the customer values. Why would we do new kind of reactors? Over the past 70 years, we have developed solid fuel reactors, right? Most of them that we have commercially. So why would we do liquid fuel reactors? So Laure, what are the customer values that we can have with molten salt reactors?
Yes, because we all work in nuclear, and in nuclear we are all very proud of what we are doing from a technical perspective, but at some point it needs to come with commercial traction, so that means that it's very good to make technology push, but if there is no market, it's a very nice technology push that will never go somewhere. So the target is really to identify the market that the molten salt can unlock. So I will talk with the first one, and then Nicolas will explain about the other ones. The first one is really the decarbonation of heat. So, as you all know, nuclear has been used mainly as electricity production, and we have, especially in France, but not only in various countries, it's mainly a way to produce electricity and decarbonize electricity. But, and especially with the huge decarbonation challenge that we have ahead of us, a lot of industries, they need to decarbonize, but they cannot only electrify their process. And they reach, I would say, a limit in terms of decarbonation. And indeed, a lot of them are using heat that is today produced by either coal, gas, or when they move to biomass and so on. And indeed, if you are able to find a nuclear process, so nuclear type of reactor, to be able to reach very high level of heat, you can address this very specific issue of a lot of industry. And today, especially in Europe, all those industries are in an energy crisis, so they are really in a need for a solution. Molten salt reactor has the ability to go to more than 500 degrees C, so they can produce a heat on a 24/7 way, so the stable output, as you can see on the electricity production, and that's really a solution for this topic for the industry. Another end user case that I can mention is also the cogeneration. So hydrogen production can be a very good driver for all those industries. In a lot of countries, hydrogen has also been seen as a way to store the electricity, which was always a difficulty, a big challenge regarding the storage. But you need to find a way to produce this hydrogen in a competitive way. And indeed, you can think with molten salt reactor about end user case where you can provide a mix of electricity and heat that will enable hydrogen production at a very competitive cost. It's what we call cogeneration, and that's the second end user case that you can have for molten salt reactor. And the third one that Nicolas will present is about electricity production.
Yeah, so of course, molten salt reactor can be used for power. We think that molten salt have great value that is additional versus existing nuclear power. As molten salt have homogeneous liquid fuel, we are mixing fertile atoms and fissile atoms homogeneously, which means that we can actually provide a breed and burn reactor that can renew 100% of its fuel online inside the reactor. So the great value for customers is that you can guess having a data center that is xScale data center like 500 megawatt, fully sustainable, while you onboard the power straight away at the very beginning, and then you get the power for the whole lifetime. So this is something that nobody can do, and that has a great traction. We already have pre-orders from the leader of data center called Equinix. They have 250 data centers around the world, and they want to build the next generation of data centers with Stellaria. And the only way that they can build that sustainably is to have decarbonized power that is renewable. There will be also more difficulties and tension on the uranium market after 2032. And having the possibility to close the cycle, not totally, but close the cycle inside the reactor, can provide huge autonomy and secure the business plan for customers. Another use case is retrofitting coal power plants. The molten salt reactor provides a temperature set that is fully compatible with existing coal installation. So for example, in Poland, there are a lot of cogeneration with around 250 to 350 megawatts that use coal today that can be retrofitted with molten salt reactors. So why it's very interesting is because you can keep the personnel, you can keep the electrical distribution, and you just have to change the burners into molten salt reactors on the same footprint. So the next question is about, of course, sustainability. Yeah.
Maybe,
so
maybe
Isabelle,
I can say a word about another application.
Yeah, sorry, Isabelle. So
Thank you.
Regarding the value, customer values, there is another use case that is super important. It's about closing the cycle and
No, it's
I will let you.
Yes. Because I said previously that molten salt reactor can use a lot of different salt, and in particular fissile materials. One of our interests in Orano was the ability, which is quite unique, to use the minor actinides as fuel. And minor actinides, it's a waste today, but because you cannot recycle it. Minor actinides are today in the West. It's a very radiotoxic material with a very long life, thousands of years. But if you use a molten salt reactor with a fast spectrum, you could use these minor actinides and burn it or fission it to fission products. We have a shorter life. And this is very interesting because with this, you could reduce the volume and the radiotoxicity of the waste. Not the reactor itself, of course. You need the complementarity between the reactor, the molten salt reactor, and a reprocessing plant like the one we have in Orano, La Hague. And this is why we are interested. It's the synergetic aspect between the molten salt reactor and the value proposition that we have already implementing in La Hague by recycling the fuel. By doing so, we already recycle or we can reuse 96% of the material still in the spent fuel. It's uranium and plutonium that we extract from the spent fuel in La Hague to be reused in other fuels. We could do one step further in the closure of the fuel cycle by using minor actinides, and by the same way reduce the waste. This is why it's so interesting.
Thank you, Isabelle. We'll talk about sustainability now. So why we are here together is because we are sharing. We have a sharing group with Orano and with Thorizon, and we co-developed the R&D on the fuel itself to grow a new sector because we think that a startup by itself cannot do it on its own. So that's why we work together. So now let's talk a bit more about sustainability. Laure, what the molten salt can bring in terms of sustainability?
I think it has been mentioned, but I will go a bit into detail. What can we put in a molten salt reactor? Because indeed, So you understood, in molten salt reactor, we can unlock a lot of additional end-user case that both Isabelle, Nicolas, and I mentioned. And the major advantage for the molten salt reactor is the versatility, as Isabelle said, of the fuel. What does it mean? Is when you have a liquid fuel, in fact, you can put a lot of various isotopes in it, so fissile, fertile, to make sure that you have the chain reaction. So that means that you have a lot of possibility and you can unlock a lot of various, I would say, ways of creating energy. So indeed, you can use materials that are coming from the spent fuel. So we can think about the PU. You can think also about the reprocessed uranium that is also produced in La Hague. You can think about the minor actinide, but you can also think about fertile material, such as the depleted uranium. So for example, the depleted uranium that comes from the enrichment plant. You can think also of various, I would say, isotope for the uranium. So it can be LEU, it can be LEU+, it can be HELIU. So indeed, that unlocks a various possibility to use isotope and to generate energy from those isotopes, which make it very complementary to a standard nuclear fleet. Meaning you can think about a standard nuclear fleet, I would say based on a uranium cycle. And on top of that, you can think about a complementary molten salt fleet that will be, as a complement, burning, generating the fuel for these conventional fleets. And this part will be explained by Nicolas.
Yes, so regarding the molten salt, there is a change in paradigm, because today you have to change the fuel every 36 months, right? On molten salt, it's slightly different. You can keep the salt on site for many, many years, dozens of years, and you actually change the vessel itself. So that's a big change on the way we manage the molten salt reactors versus solid fuel reactors. It means that there is a long life cycle, so the uptime of the fuel is very long, and it provides less transportation, and also it allows the capacity to isogenerate on site and provide isogeneration, so the regeneration of the fuel on site for quite a long time. So we think this is very sustainable in a world where there is a lot of Gen 3 programs that will grow around the world, and there is complexity and tension on the mining side. Isabelle, so what's your point? What's your opinion on the transportation and on the fuel reprocessing?
Yes, thank you. So I will come back always, as before, on the value proposition about minor actinides. I think it's all about recycling the fuel in general, multi-recycling the fuel. So we, just to let you understand clearly, we already have an industrial plant doing this in La Hague. Treatment and recycling of the fuel is implemented at industrial scale at La Hague, and it's already a major contribution to sustainability, because with this recycling, you can save already 25% of natural uranium. You can also reduce the radiotoxicity volume by a factor of 5, and the radiotoxicity level by a level of factor of 10. So it's already implemented at industrial scale. And France is also working on multi-recycling scenario in light WR and also in fast reactor. So molten salt reactors have all their place in this panorama or landscape of multi-recycling possibilities. And as Laure said, it could be several strategy. You can use them to multi-recycle uranium and plutonium, as you said. And for us, we are more interested in the long-term strategy of burning minor actinides. Of course, that's the ultimate stage of development. It will not happen in the next 5 or 10 years. It's a long-term strategy, but it's really a kind of ultimate goal in terms of sustainability and also in terms of acceptance for the public of the nuclear energy. This is why we think it's important to go this route. And the development, what is nice to say is that the development of the fuel can be mutualized between all the developers of molten salt reactor, because in fact it's actually the same bricks. The salt itself is made of a few components: chloride, uranium, chloride, plutonium, etc. So a few, voilà, NaCl, of course. So you can mutualize the development, and this is what we are doing. First in France 2030 program, phase 1, because we have consortium to develop the fuel together. And more recently, in 2024, as Nicolas said, we launched what we call the sharing group, which is a way to optimize the cost and the resource on the development of the fuel cycle. All this is consistent.
So to conclude, molten salt reactors are really the champions of the circular economy of the fuel, but also on the reactor side, because as you understood, the concept is slightly different versus solid fuel. You can change everything inside. So once you have done the installation, it can last for years. I like to compare that with dams. Basically, you will install the civil engineering and you can change everything inside. And the fuel once the fuel is polluted with fission products, it's not thrown away. It can be cleansed a second time in the reactor, back in the reactor, because there is still the same amount of fissile atoms available in the fuel. Thank you very much for your time, and we will go for the questions.